Here we want to describe the motion of a particle with position xy as t varies in a given interval. X is equal to 5 times the sine of t, y is equal to 2 times the cosine of t, where t is in between negative pi and 5 pi. So the first thing we need to do is look at the first part of our parametric equation, x, which is equal to 5 times the sine of t. If we divide both sides by 5, then we have x over 5, which is equal to sine t. Similarly, if we do the same thing for y, which is equal to 2 times the cosine of t, divide both sides by 2, and therefore y over 2 is going to equal the cosine of t. Now remember that we have the trig identity, where we have sine squared t plus cosine squared t is equal to 1, which means that we can take the value of whatever sine of t is, which is x over 5 from a previous step, squaring that, plus we have y over 2 squared, and that's equal to 1. So with this equation, we can see that this creates an ellipse. So this is the graph of the ellipse. We have the value under x, which is 5, negative 5, and then we have 0, 2, and 0, negative 2. You can also put this equation into Desmos and graph that. So x divided by 5, and we're going to square that, and then we put plus, and then we put in y divided by 2, and we can square that, and then we can set that equal to 1. So here we can have our ellipse if we wanted to graph that on Desmos. So here is our ellipse. Now we want to describe what's happening with the particle. So what we can do is, let's go ahead and create a quick table here. So we have t, and we're starting at negative pi, and we're ending at 5 pi. And so what do we get when we put x, and what do we get for y? So if we go ahead and put in our value for negative pi and 5 times the sine of that, so 5 times the sine of negative pi, well, that gives us 0. And then if we put 2 times the cosine of negative pi, let's do that again, 2 times the cosine of negative pi, we get negative 2. So here at 0, negative 2, this is our starting point. This is our initial point. So that means it's starting here, where t is equal to negative pi. Then we have 5 pi, so let's go ahead and put that in there. So we have 5 times the sine of 5 pi, which gives us 0. And then we have 2 times the cosine of 5 pi, which gives us negative 2. So we end up back here. So what does that tell us? Well, what that tells us is that the motion of the particle takes place on an ellipse centered at 0, 0, because that's where the ellipse is at, centered at 0, 0. As t goes from negative pi to 5 pi, the particle starts at the point 0, negative 2 and moves clockwise around the ellipse 3 times. So that means we have, if we're starting here on the ellipse, so we're moving in a clockwise direction. So here we have one full rotation, so there's one. And then two. And then 3. And it finishes at 5 pi.